Section 7.5, the method of partial fractions. So yet another method that will allow us to evaluate integrals. So what is the method of partial fractions? So what this is, it's going to allow us to integrate rational functions. So a rational function is something, let's say f of x is p of x divided by q of x, where these are both polynomials. So for example, what here is a rational function, x squared minus 3x plus 7 over x cubed plus 6x squared minus 2. This is a rational function. And so what partial fractions is, the method of partial fractions, it's a method that allows us to rewrite rational functions in a different form that, for integration purposes, will make it easier for us to integrate. Now, it's worth noting that the method of partial fractions, and closely related to that, undetermined coefficients, you'll see what I mean by that in future videos. This is useful right here in this section for us to do integration, but these tricks are certainly things that work not just when you're doing integration, but in other parts of math. So I can certainly think of in differential equations, these come up. I've certainly seen engineering applications, partial fractions, undetermined coefficients. These things come up later in your math career. So partial fractions isn't just important as an integration technique, but also as a larger math tool. Okay, so that's a bit of philosophical rambling. What is going on here? So suppose I asked you to integrate 1 over x squared minus 1. Okay, so let's observe this doesn't fall into any of our previous buckets. It's not directly doable. I don't see a substitution we can do. I don't see a way to do this by parts. None of our usual methods are going to work here. However, here is the key trick. So, suppose I tell you the following is true, that 1 over x squared minus 1 is equal to 1/2 divided by x minus 1 minus 1/2 divided by x plus 1. Now, don't worry about where this comes from. We'll talk about where this comes from in the near future. But if I tell you this is true, know that at least it's easily checkable. If we put these two terms over a common denominator, so that common denominator would be x minus 1 times x plus 1, and we'd end up with 1/2 times x plus 1 minus 1/2 times x minus 1. This expands out to x squared minus 1, which is that, and 1/2 x plus 1/2 minus 1/2 x minus 1/2. So that should be a minus 1/2 times minus 1 plus 1/2. Cancel, 1/2, 1/2. Add those together, and you get 1 over x squared minus 1. So right now we don't know how I went from here to here, but we can see these two are clearly equal to each other. You know, usually I give you this kind of expression. It's not too hard to go to here. We're kind of running the process in reverse. One might say we're unsimplifying things. So here's the payoff. So what does this have to do with integration? Well, we can rewrite 1 over x squared minus 1 as in exactly this way. And at this point then, if we want to really write everything out here, it's just the difference of two integrals. That is some separate minus sign there. Let me make that a little bit clearer here. And both of these are very simple integrals for us to do. So what's the point of partial fractions? The method of partial fractions, we rewrote our rational function in terms of two other rational functions. We didn't know how to integrate this, but these two rational functions are each ones that we can easily integrate. So this is what the method of partial fractions is. We rewrite rational functions in ways that allow us to more easily integrate them. So the key step here, what's the hard part of this problem? The hard part of this problem is going from here to here. So in the next video, we'll see how to go from here to here, and we'll work through examples all the way from scratch.